Hello there. Take a slow breath in and let it out gently. Tonight, we're going to look at something peaceful together, something quiet and calm. We're going to imagine looking down on our planet from far above, from the silence of space. But there's no rush to get there. We can take our time. You can close your eyes whenever you want. You can drift off at any moment. Nothing here is important to remember. From space, Earth looks very different than it does from down here where we stand. Up there, in the quiet darkness beyond our atmosphere, our planet appears as a gentle sphere, a soft blue marble floating in the endless black. It's a peaceful sight, a calming image, and tonight we're just going to sit with that feeling for a while. When astronauts first traveled beyond Earth's atmosphere, they looked back and saw our world from a distance for the very first time. They described it as beautiful, as peaceful, as something that made them feel calm inside, even though they were so far from home. And that's the feeling we're looking for tonight, that gentle, quiet feeling of seeing Earth from far away. Our planet looks blue from space. This is because of our oceans. Water covers most of Earth's surface, about 70% of it, and water reflects blue light from the sun back into space. So when you look at Earth from far above, the first thing you notice is that soft blue color. It's not a bright, harsh blue. It's a gentle blue, a calming blue, the kind of blue you might see just after sunset, when the sky is starting to fade into night. But Earth isn't just blue. There are other colors too. Soft whites from clouds that drift slowly across the atmosphere, browns and greens from the continents, though these are harder to see because the land takes up less space than the oceans. And sometimes, if you look carefully, you can see touches of white at the very top and bottom of the planet. These are the ice caps, the frozen areas at the poles where it's always cold. The clouds are especially peaceful to watch from space. They move so slowly across the planet's surface, great white swirls that spiral gently over the oceans. They form patterns, soft, flowing patterns that change day by day, hour by hour. But from space, you can't really see them changing. They move too slowly for that, so they just look still, quiet, frozen in a gentle moment of time. At night, when the sun isn't shining on part of Earth, you can see something else. You can see lights, small points of light scattered across the dark parts of the planet. These are cities, towns, places where people live and work and rest, just like you're resting right now. From space, these lights look like tiny stars sprinkled across the darkness. They twinkle softly, they glow in warm yellows and oranges, and they remind us that even though space is vast and dark and quiet, there are millions of people down there, living their lives, sleeping in their beds, dreaming their dreams. The atmosphere around Earth looks very thin from space. It's a delicate layer, a gentle blanket of air that wraps around our planet and keeps us safe. From far away, you can see it as a soft blue glow along the edge of Earth. It's brightest where the sun hits it at just the right angle, and it fades gently into the blackness of space. This thin layer is all that stands between us and the vacuum of space, but it's enough. It's been enough for billions of years, and it will be enough for billions more. Our atmosphere is about 100 kilometers thick, Though it doesn't have a sharp edge, it just gradually fades away as you go higher and higher. The air gets thinner, the pressure drops, until eventually there's almost nothing left, just the occasional molecule drifting alone in the darkness. But that 100 kilometers is plenty. It's enough to scatter sunlight and give us blue skies during the day, enough to burn up meteors before they reach the ground, enough to keep our air and water from drifting away into space. When astronauts describe looking at Earth from the International Space Station, they often talk about how thin that atmosphere looks, how fragile it seems, but they also talk about how beautiful it is, how seeing that thin blue line against the blackness of space fills them with a sense of peace, a sense of home. Even though they're floating 400 kilometers above the surface, they still feel connected to Earth because they can see it right there, glowing softly in the darkness. The International Space Station orbits Earth about 16 times every day. It travels at a speed of around 28,000 kilometers per hour. That sounds very fast, and it is. But from inside the station, you don't feel like you're moving at all. You float in weightlessness. You look out the window, and Earth drifts below you slowly, peacefully, as if you're standing still and the planet is the one that's moving. Every 90 minutes, the station completes one full orbit around Earth. So every 90 minutes, astronauts on board see a sunrise and a sunset. The sun rises over the curve of Earth, flooding the windows with warm golden light. Then, 90 minutes later, it sets again, and darkness returns. This rhythm continues, over and over, day by day, 16 sunrises, 16 sunsets. A gentle, predictable pattern that marks the passage of time in space. During the day passes, when sunlight is streaming through the windows, the view is clear and bright. You can see continents, oceans, cloud formations. The details are sharp and beautiful. But during the night passes, when Earth's shadow covers everything, the view changes. The planet below becomes dark. But it's not completely dark. There are lights, city lights that glow like fireflies scattered across the darkness. And if you're lucky, you might see lightning storms flickering inside clouds, or the soft green curtains of the aurora dancing near the poles. The aurora is one of the most peaceful sights you can see from space. It happens when particles from the sun interact with Earth's magnetic field and atmosphere. These particles get funneled toward the poles, where they collide with air molecules and cause them to glow. From the ground, the aurora looks like curtains of light waving in the sky, greens and blues, and sometimes reds or purples. But from space, from above, the aurora looks different. It forms a perfect ring around each pole, a circle of soft, glowing light that pulses gently in the darkness. Astronauts say the aurora is one of the things they miss most after returning to Earth, not because it's exciting or dramatic, but because it's so peaceful, so quiet. It reminds them that Earth is more than just rock and water. It's a living system, a planet with a magnetic field that protects us, an atmosphere that glows when touched by the sun, a home that takes care of us in ways we don't always see or think about. From space, you can't see borders between countries. You can't see walls or fences or lines drawn on maps. All of those things disappear when you look at Earth from far enough away. What you see instead is one continuous surface, oceans flowing into oceans, land masses connected by thin strips of Earth, everything part of one whole, one planet, one home for all of us. This is something many astronauts talk about when they return from space. They talk about how seeing Earth without borders changed the way they think about the world, how it made them feel connected to everyone and everything on the planet, not in a dramatic way, not in a way that demands action or urgency, just in a quiet, peaceful way, a way that sits with you, a way that makes you feel a little bit calmer, a little bit more at ease. At night, when you're lying in bed, you can think about this view if you want. You can imagine looking down at Earth from high above, seeing the soft blue sphere floating in the darkness, seeing the lights of cities scattered across the night side, seeing clouds drifting slowly over oceans. It's a peaceful image, a calming thought, and it can help you relax, help you let go of the day, help you drift gently into sleep. Earth rotates once every 24 hours. This is what gives us day and night. As the planet spins, different parts of the surface move into sunlight and then back into shadow. From space, you can watch this happen. You can see the line between day and night, called the terminator, moving slowly across the surface. On one side, everything is bright and clear. On the other side, everything is dark and quiet. And right along that line, right at the edge between light and dark, you can sometimes see the most beautiful sunrises and sunsets. The sun itself looks different from space. It's brighter, harsher. Without an atmosphere to scatter and soften its light, the sun becomes a pure point of white brilliance. It's too bright to look at directly, even with the windows of a spacecraft. But when it rises over the curve of Earth, when it first appears above the horizon, there's a moment of soft color, a brief flash of orange or red or gold, and then it's up, and the harsh white light returns. But we're not here to think about harsh light. We're here to think about peaceful things, calming things. So let's return to Earth, to that soft blue sphere, to the gentle patterns of clouds and oceans, to the quiet darkness of space surrounding it all. One of the most peaceful times to view Earth from space is during the early morning hours, just before sunrise. The planet is still mostly dark. Most people are asleep, just like you might be soon. The lights of cities are still glowing, but they're fewer now than they were earlier in the night. And there's a quietness to it all, a sense of stillness, as if the whole planet is resting, taking a breath, preparing for another day. In these quiet hours, you can see weather patterns more clearly. Great spiral systems of clouds rotating slowly over the oceans. These are storms, but from space, they don't look dangerous or frightening. They just look like patterns, like giant pinwheels of white against the blue. They move so slowly that you can watch them for hours and barely see any change. They're peaceful in their own way, reminders that Earth is always in motion, always changing, but always doing so slowly, gently, without hurry. The oceans themselves are fascinating to watch from space. They're not a uniform blue. There are lighter areas and darker areas. Shallow water near coastlines appear in lighter shades of blue, or even turquoise. Deeper water, far from land, appears in darker, richer blues. And sometimes you can see currents, long streaks of slightly different color where warm water and cold water meet and flow alongside each other. These currents move vast amounts of water around the planet. They help regulate Earth's temperature. They carry nutrients from one part of the ocean to another. They affect weather patterns and climate. But from space, they're just peaceful lines of color, gentle variations in the blue, nothing urgent, nothing demanding your attention, just another part of the quiet complexity of our planet. If you follow the coastlines from space, you can see how intricate they are, how they curve and bend, how they form bays and peninsulas and islands. Some coastlines are smooth and simple, others are jagged and complex, with thousands of tiny islands scattered just offshore. Each coastline tells a story of how the land and sea have interacted over millions of years. But you don't need to know those stories. You can just look at the shapes, the patterns, the way the blue of the ocean meets the brown and green of the land. Islands are especially peaceful to look at from space. They appear as small dots of land surrounded by vast expanses of blue. Some are so small you can barely see them. Others are large enough to have their own mountains and forests. But they all share that same quality, that same sense of being separate, apart, alone in the ocean. And yet they're not really alone. They're connected to Earth, part of the same planet, part of the same gentle blue sphere floating in space. The poles of Earth look different from the rest of the planet. The Arctic at the top and Antarctica at the bottom are covered in ice and snow. From space, they appear as brilliant white caps. The ice reflects sunlight very efficiently, making these areas some of the brightest parts of the planet. During certain times of year, the ice extends further from the poles. During other times, it retreats. This yearly cycle has been happening for thousands of years, a gentle rhythm of freezing and melting, expanding and contracting. Antarctica is particularly striking from space because it's almost entirely white. It's the coldest place on Earth, the windiest place, the driest place, even though it's covered in ice. But from space, you can't feel the cold or the wind. You just see the white expanse, the peaceful, pristine emptiness of it. And it reminds you that Earth is a planet of extremes, of places so cold that nothing grows, and places so warm that life explodes in abundance. But all of these places, all of these extremes exist together on one small planet, one gentle blue sphere.
The Arctic is different from Antarctica because it's mostly ocean covered by floating ice, rather than land covered by ice. This ice moves. It drifts with ocean currents and winds, and in recent decades, the amount of ice in the Arctic has been changing. But from space, on any given night, it still looks peaceful, still looks white and calm, still looks like a natural part of Earth's beauty. Around the equator, where Earth is widest, the view from space is particularly rich in color. This is where you find tropical rainforests, where you find the warmest oceans, where clouds are thick and tall and full of moisture. The greens are deeper here. The blues are brighter. Everything seems more vibrant, more alive, but still peaceful, still part of the same gentle rhythm that covers the whole planet. You might wonder what it feels like to be in space looking down at Earth. Astronauts describe it as surreal, as dreamlike. They say it doesn't feel quite real, even though they know it is. They say it's hard to put into words, hard to capture in photographs, even though they take thousands of them. Because what makes the view special isn't just what you see, it's what you feel, the quietness, the perspective, the sense of being very far from home and yet still connected to it. There's a term that some astronauts use called the overview effect. It's the name for the feeling that comes from seeing Earth as a whole, from understanding in a deep and personal way that our planet is small and fragile and alone in the vastness of space, that everything we've ever known, everyone we've ever loved, every problem we've ever worried about exists on this one small sphere. And that sphere is beautiful and peaceful and worth protecting. But we don't need to be in space to experience a bit of this feeling. We can lie here in our beds, in the darkness, and imagine it. We can picture Earth floating below us. We can picture the soft blue glow, the white clouds, the scattered lights of cities at night. And we can let that image calm us, help us feel connected to something larger than ourselves, something peaceful and enduring. The moon, Earth's only natural satellite, is often visible from space when you look at Earth. It appears as a gray sphere, smaller than Earth, hanging in the blackness nearby. The moon doesn't glow on its own. It reflects sunlight, just like Earth does, and depending on where it is in its orbit, it might appear as a full circle, or as a crescent, or anything in between. From space, the moon looks close to Earth, but it's actually quite far away, about 384,000 kilometers, far enough that it takes light more than a second to travel from Earth to the moon. The moon and Earth are partners in space. They orbit each other, or more accurately, they both orbit a common point between them. The moon's gravity pulls on Earth, causing tides in our oceans. Earth's gravity keeps the moon in orbit. They've been locked in this dance for billions of years, and they'll continue for billions more. It's a peaceful relationship, a stable relationship, one that requires no effort or attention. It just is. Sometimes from space, you can see both Earth and the moon in the same view. Earth, large and colorful and alive, the moon, smaller and gray and still. The contrast between them is striking, but peaceful. It reminds you that not all worlds are like ours, that Earth is special, that the conditions that allow for oceans and clouds and life are rare and precious. But it's not a thought that brings anxiety. It's a thought that brings comfort, gratitude, a quiet appreciation for what we have. When spacecraft travel beyond Earth orbit, when they venture out into deep space, they sometimes turn their cameras back toward home. And when they do, Earth appears even smaller. From the moon, Earth is still clearly a sphere, still clearly blue, still recognizable. But from Mars, Earth is just a bright star in the darkness. And from even further away, from the edge of the solar system, Earth becomes a pale blue dot, a single pixel in a photograph, almost invisible, almost lost in the vastness of space. There's a famous photograph called Pale Blue Dot, taken by a spacecraft that had traveled far beyond the planets. In that image, Earth is barely visible, just a tiny speck suspended in a beam of sunlight. When you look at that photograph, you realize how small we are, how vast the universe is, how quiet and dark and empty most of space really is. And somehow that realization is comforting, because it means that here on Earth we have something special. We have warmth, light, air to breathe, water to drink, life, and we can appreciate these things without taking them for granted. But let's return to our closer view, to the view from just a few hundred kilometers up, where Earth still fills the window, where you can still see details, where you can still feel connected. This is the view that astronauts live with every day when they're in space, and it's the view that helps them feel at home even though they're far from the surface. During the day, when sunlight illuminates Earth's surface, you can see mountains if you look carefully. The tall peaks cast shadows, and these shadows make the mountains visible from space. The Himalayas are particularly striking. They form a long curved line of white peaks, covered in snow even in summer. From space, they look like wrinkles in Earth's surface, like the planet is folding in on itself just a little bit, creating these high places where the air is thin and the wind is strong, and the view stretches for hundreds of kilometers in every direction. But most of Earth's surface is much smoother than the mountains. Most of the land is relatively flat, gently rolling hills, wide plains, vast deserts that stretch for thousands of kilometers with almost no variation in height. And the oceans, of course, are smoother still. The waves that seem so large when you're standing on a beach are completely invisible from space. Even the largest storms create swells that are too small to see from orbit. So the ocean looks calm, always calm, a perfect blue surface that reflects the sky. Rivers are visible from space too, though you have to look carefully to see them. They appear as thin, winding lines cutting through the landscape. Some are brown with sediment, others are blue, reflecting the sky above. They meander across continents, always moving downhill, always seeking the ocean, and eventually they find it. They flow into bays or estuaries or deltas, where fresh water meets salt water and the river finally comes to rest. The Amazon River is one of the most visible rivers from space. It's so wide in places that it looks more like a lake than a river, and its delta, where it flows into the Atlantic Ocean, is vast and complex, a maze of channels and islands where the boundary between river and ocean becomes blurred. From space, you can see sediment from the Amazon flowing out into the ocean, a brown plume extending hundreds of kilometers from the coast. The river carries so much sediment, so much soil from the interior of South America, that it changes the color of the ocean. Even from space, you can see this. You can see the impact that one river has on the entire ocean around it. But again, there's nothing urgent here. Nothing that demands attention. It's just another peaceful pattern, another example of how Earth is always changing, always moving, but doing so slowly, gently, in ways that only become visible when you step back and look at the big picture. Deserts are also striking from space. They appear in shades of brown, orange, red, and yellow. Each desert has its own color, determined by the rocks and soil that form it. The Sahara, the largest hot desert in the world, appears as a vast expanse of tan and orange. It covers much of North Africa. From space, you can see sand dunes, though they're just barely visible. Great curved lines that mark where the wind has shaped the sand over many years. The desert looks peaceful from space, empty, still, a place where time moves slowly and little changes from year to year. Australia, when you look at it from space, is particularly interesting because so much of its interior is desert. The continent appears mostly red and brown, with green only around the edges where rain is more common. The red color comes from iron oxide in the soil. It's the same color as rust, and it gives Australia a warm, earthy tone that's different from any other continent. From space, Australia looks ancient, weathered, like it's been there forever and will be there forevermore. Clouds, as we mentioned before, are one of the most dynamic things you can see from space. They form and dissipate.
They move with the wind. They change shape. But even though they're always changing, they never feel rushed, never feel frantic. They drift, they float, they take their time, and watching them is peaceful. It's like watching water flow in a stream. There's constant motion, but it's gentle motion, motion that doesn't demand anything from you. There are different types of clouds, and each type looks different from space. Some clouds are thick and tall, rising high into the atmosphere. These are thunderstorm clouds, and from space they look like great white towers. But you can't hear the thunder from orbit, you can't feel the rain. You just see the bright white mass, and sometimes at night you can see lightning flickering inside it like a tiny strobe light. Other clouds are thin and wispy, stretched across the sky in delicate patterns. These are high-altitude clouds made of ice crystals, and they barely cast a shadow on the ground below. And then there are the clouds that form in spirals. These are tropical cyclones, or hurricanes, or typhoons, depending on where they form. From space, they look beautiful, perfectly circular, with a clear eye in the center, surrounded by bands of clouds spiraling outward. They look almost artificial, like someone designed them. But of course, no one did. They form naturally when conditions are right, when the ocean is warm enough and the atmosphere is unstable enough, and they can grow to be hundreds of kilometers across. From space, they look peaceful, but down below, they bring wind and rain and sometimes destruction. Still, from our distant view, we see only the pattern, only the beauty, only the quiet majesty of nature doing what it does. As you lie here tonight, you can imagine all of this. You can imagine floating above Earth, looking down at the gentle blue sphere, seeing clouds drift across oceans, seeing the thin line of atmosphere glowing at the edge, seeing the scattered lights of cities in the darkness. And you can let this image relax you. There's no need to understand everything, no need to remember details. Just let the peaceful feeling wash over you. Let yourself drift, just like the clouds drift across the planet below. Earth spins beneath you, slowly, always moving from west to east. This rotation is what causes the sun to appear to rise in the east and set in the west. But from space, you're not really aware of the rotation. The planet just seems to be there, constant, unchanging, even though it's moving, even though you're moving, even though everything is always in motion. From space, there's a sense of stillness, a sense of peace, because the movements are so smooth, so constant that they feel like no movement at all. Gravity keeps everything together, keeps the atmosphere from drifting out into space, keeps the oceans on the surface instead of floating off into the void, keeps us and everything else grounded. Gravity is invisible. You can't see it or touch it, but you can see its effects everywhere, in the way water flows downhill, in the way clouds sink when they get too heavy with moisture, in the way the moon stays in orbit around Earth, and Earth stays in orbit around the sun. Gravity is the force that holds everything together, and it does so quietly, peacefully, without any fuss or drama. The sun provides the energy that drives almost everything on Earth. It heats the oceans, it evaporates water to form clouds, it powers the wind, it allows plants to grow, and plants, in turn, provide food and oxygen for animals. Everything is connected. Everything depends on everything else. And at the center of it all is the gentle warmth of sunlight falling on our planet day after day,
year after year for billions of years. But the sun also creates the day and night cycle that we experience here on the surface. As Earth rotates, we move in and out of sunlight. Right now, as you rest here in the darkness, the sun is shining on the other side of the planet. People over there are experiencing daytime. They're going about their lives, working, playing, talking, laughing. And in a few hours, when the planet has rotated a bit more, the sun will rise here too. A new day will begin. But for now, it's night, it's dark, it's peaceful, and that's exactly where we want to be. Night is a special time when you view Earth from space. The planet takes on a completely different character. During the day, it's all about colors, blues and greens and whites and browns. But at night, it's all about lights, the lights of human civilization scattered across the dark surface. Each light represents a home, a street, a building. Each light represents people living their lives. And from space, all of those individual lights blend together into a soft glow, a gentle reminder that we're not alone, that we're part of something larger, part of a global community of billions of people, all sharing this one small planet.
Some areas are brighter than others. Cities are bright, towns are dimmer, rural areas are dark, with only occasional lights scattered here and there. And some places are completely dark. The oceans, of course, the deserts, the forests, the mountains. These places have no lights at all. They're just dark spaces on the night side of Earth. But that darkness is peaceful too. It's a reminder that not everything is human, that there are still wild places, still quiet places, still places where nature exists without our influence. Looking at Earth's lights from space, you can see patterns. You can see where people have chosen to live. They cluster along coastlines, along rivers, in valleys and plains. They avoid the mountains mostly. They avoid the deserts. They go where water is available, where the land is flat enough to build on, where the climate is mild enough to be comfortable. And over thousands of years, these choices have created the patterns of light we see today. Bright clusters in some places, dimness in others, darkness everywhere else. The lights are beautiful, but they're also very small. Even the brightest city, when viewed from orbit, is just a small glow against the vastness of Earth's surface. And when you zoom out even further, when you imagine looking at Earth from the moon or from Mars, those lights disappear entirely. They're too small to see, too faint to register. From a great distance, Earth is just a planet, just a sphere of rock and water and air. The lights, the cities, the billions of people, all of that becomes invisible. And there's something humbling about that, something peaceful. It reminds us that we're part of something much larger than ourselves. My name is Ilara, by the way, and this is the Late Night Science Channel. But that's not important right now. What's important is that you're relaxed, that you're comfortable, that you're letting your mind drift along with these quiet thoughts about Earth and space and the peaceful view from above. If you're enjoying this calm time together, you're welcome to subscribe to the channel, but only if you want to, only if it feels right. There's no pressure, no urgency. This is just a quiet space where you can come and relax whenever you need to, whenever the world feels a little too loud or a little too fast, whenever you need a reminder that there's peace out there, that there's stillness, that there's a bigger picture that puts everything into perspective. The space around Earth is not completely empty. There are satellites up there, thousands of them. They orbit at different heights, serving different purposes. Some provide internet and television signals. Others monitor the weather. Others still are used for scientific research, studying Earth's atmosphere or magnetic field or climate. These satellites are small, much smaller than the space station. And from Earth, most of them are completely invisible. Even at night, when the sun reflects off their surfaces, they're just faint points of light moving slowly across the sky. You might see one if you know where to look, if you're patient, but mostly they go unnoticed. These satellites are tools. They help us understand Earth better. They help us communicate across vast distances. They help us predict storms and track ocean currents and measure ice thickness at the poles. But from the perspective of someone in space looking at Earth, they're barely worth noticing. They're just tiny specks, little man-made objects floating in the void. What matters is Earth itself, the planet, the home, the gentle blue sphere that has everything we need to survive and thrive. Beyond the satellites, beyond the space station, even beyond the moon, there's just emptiness, just the darkness of space stretching out in all directions. There are stars, of course, billions of them, but they're so far away that they're just points of light. They don't illuminate anything. They don't provide warmth. They're just there, silent witnesses to everything that happens in the universe. And when you look at Earth from space, when you see it floating alone in that vast darkness, you realize how special it is, how rare, how precious. But we don't need to think too deeply about that. We don't need to analyze it or understand it completely. We can just sit with the image, just hold it in our minds. Earth, blue, peaceful, slowly turning in the darkness, wrapped in its thin blanket of air, covered in oceans and clouds, dotted with lights at night, home to billions of people, home to us. Earth has been here for a very long time, about 4.5 billion years. It formed from a cloud of dust and gas that collapsed under its own gravity. Over time, that dust came together to form rocks. The rocks came together to form a planet. The planet cooled. Water collected on its surface. An atmosphere formed. And eventually, life began. All of this took billions of years, an almost inconceivable amount of time. But it happened slowly, gently, without a rush. And Earth will be here for a very long time to come. The sun will continue to shine. The planet will continue to spin. The seasons will continue to change. Life will continue. Not forever, perhaps. Nothing lasts forever. But for a very, very long time. Long enough that we don't need to worry about it. Long enough that we can just relax and appreciate the present moment. This moment, right now, as you lie here in the darkness, breathing slowly, feeling peaceful and calm. From space, you can't see individual people. You can't see cars or trees or buildings, not clearly anyway. What you see is the big picture, the overall impression, the general feeling. And that's okay, because the big picture is peaceful, it's beautiful, it's reassuring. It reminds us that while our individual problems and worries might feel huge to us, from a broader perspective, they're quite small. And that's not meant to minimize them. It's meant to provide perspective, to help us realize that we're part of something much larger than ourselves, and that connection is a source of comfort. When you can't sleep, when your mind is racing, when you're worried about tomorrow or regretting yesterday, it can help to think about this view, to imagine yourself floating above Earth, watching clouds drift across oceans, seeing the thin glow of atmosphere at the edge, seeing the scattered lights of cities in the darkness, and reminding yourself that you're just one person on a planet with billions of others, that everyone has their own worries and hopes and dreams, that we're all in this together, and that tomorrow the sun will rise again, the planet will keep spinning, life will continue, and whatever you're worried about right now will pass. Everything passes. Everything changes, but Earth remains peaceful, beautiful, home. The view of Earth from space has been called the most important photograph ever taken, not because of anything dramatic or exciting, but because of the perspective it provides, because of the way it makes us feel, because of the peace it brings. When you see Earth as a whole, when you see it floating alone in the vastness of space, you realize that borders and divisions are artificial, that we're all living on the same small planet, that we all share the same air, the same water, the same sun, and that realization can change how you see the world, how you see other people, how you see yourself.
But even if it doesn't change anything, even if you just enjoy the peaceful image and then move on with your life, that's okay too. Not everything needs to be profound. Not everything needs to be meaningful. Sometimes it's enough just to lie here, in the darkness, breathing slowly, thinking quiet thoughts about Earth and space, and the gentle blue sphere floating in the void. Sometimes that's all we need. The seasons on Earth are caused by the planet's tilt. As Earth orbits the sun, different parts of the planet receive more or less sunlight depending on the time of year. This tilt is gentle, about 23.5 degrees, but it's enough to create the rhythm of seasons that we experience: spring, summer, fall, winter, and then spring again, a cycle that repeats year after year, predictably, peacefully, without fail. From space, you can't really see the seasons changing. The changes happen too slowly, too gradually. But if you were to watch Earth for an entire year, you would notice differences. You would see ice expanding from the poles during winter and retreating during summer. You would see the color of certain land areas changing as plants grow in spring and die back in fall. You would see storm patterns shifting as the zone of maximum heating moves north and south with the seasons. But all of this happens slowly, so slowly that from moment to moment, from day to day, Earth looks essentially the same, constant, unchanging, peaceful. The ocean currents that flow around Earth are like rivers within the sea. They move warm water from the equator toward the poles. They move cold water from the poles back toward the equator. These currents are driven by wind, by differences in water temperature, by differences in salinity, and they flow in great circular patterns called gyres that span entire ocean basins. From space, you can sometimes see hints of these currents, places where the water is a slightly different color, places where two currents meet and create a visible line in the ocean. But mostly, the currents are invisible. They flow beneath the surface, quiet, steady, doing their work without any fanfare. These currents are important. They help distribute heat around the planet. They affect climate and weather patterns. They influence where fish live and where ships travel. But from space, they're just another peaceful part of Earth's complexity, another system working quietly in the background, another reminder that our planet is not just a static ball of rock and water, but a living, breathing, constantly moving system. And yet, despite all this movement, despite all this change, there's a sense of stability, a sense of balance, a sense that everything is working together as it should. The clouds over the ocean are often different from the clouds over land. Ocean clouds tend to be lower and flatter. They form in layers that stretch for hundreds of kilometers. Land clouds are often taller and more varied. They build up during the heat of the day as the sun warms the ground and causes air to rise. By late afternoon, you can see clusters of bright white clouds over continents, especially in tropical areas. But by night, many of these clouds dissipate. They fade away, and the sky clears. This daily rhythm of cloud formation and dissipation is yet another gentle cycle, another pattern that repeats endlessly without requiring any attention or thought from us. Rain falls somewhere on Earth almost constantly. While you're lying here in the dry comfort of your bed,
Rain is falling on forests and fields and cities and oceans in other parts of the world. From space, you can see areas of heavy rain. They appear as particularly thick and bright areas of cloud. The rain itself is invisible from orbit. The drops are too small. But the clouds that produce rain are visible. And if you watch carefully, you might see those clouds moving, drifting with the wind, carrying their rain from one place to another. Rain is essential for life on Earth. It fills rivers and lakes. It waters crops. It sustains forests. Without rain, most of the land would be desert. But rain falls in patterns. Some areas get a lot, some areas get very little, and these patterns have shaped where people live and how civilizations have developed over thousands of years. From space, you can see the results. You can see the green areas where rain is abundant, you can see the brown areas where it's scarce, and you can see the transition zones in between, where the landscape gradually changes from one type to another. Forests, when you can see them from space, appear as dark green areas. Tropical rainforests are particularly dark because they're so dense, so full of life. The Amazon rainforest, the Congo rainforest, the forests of Southeast Asia, they all appear as deep green patches on the surface of the planet. These forests are home to countless species of plants and animals. They produce oxygen, they store carbon, they influence weather patterns. But from space, they're just patches of color, peaceful, quiet, asking nothing of us except perhaps that we appreciate them. The contrast between forested areas and deforested areas can be striking from space. Where forests have been cleared for agriculture or development, the land becomes lighter in color, brown or tan instead of green. The boundary between forest and cleared land is often sharp and visible even from orbit. You can see rectangular patterns where fields have been planted. You can see roads cutting through the landscape. You can see the geometric shapes that humans create when we reshape the land. These shapes are different from the organic flowing shapes of nature, but they're part of Earth too, part of the story of how humans live on this planet. Farmland from space often appears in shades of green and brown, depending on what's growing and what season it is. Some fields are bright green with growing crops, others are dark brown, recently plowed and waiting for seeds. Still others are golden or yellow, ready for harvest. The patchwork of different colors creates its own kind of beauty, a human-made pattern that's different from natural patterns, but beautiful in its own way. From space, you can see how much of Earth's land surface has been shaped by agriculture, how much of the planet has been put to use growing food for billions of people. It's a reminder that we're part of Earth's story too, that we shape the planet just as the planet shapes us. Mountains create their own weather patterns. When moist air flows up the side of a mountain, it cools and the moisture condenses into clouds and rain. This is why mountains often have clouds clinging to their peaks, and it's why one side of a mountain range can be green and wet, while the other side is brown and dry. From space, you can sometimes see these differences. You can see how the landscape changes from one side of a mountain range to the other, how the presence of mountains affects everything around them. But it's all just patterns, just variations in color and texture. Nothing to worry about, nothing to figure out, just peaceful observations.
Volcanoes are visible from space when they're erupting. A plume of ash and gas rises high into the atmosphere, spreading out in a distinctive shape. From space, these plumes look white or gray. They drift with high-altitude winds, sometimes traveling thousands of kilometers before finally settling back to Earth. Most of the time, though, volcanoes are quiet. They're just mountains, some with snow on their peaks, some bare and rocky,
some covered in vegetation. From space, you can't tell which ones are active and which ones are extinct. They all look peaceful, all look like natural parts of the landscape. Earth has many volcanoes. Some are on land, others are under the ocean, invisible from the surface. The Ring of Fire, a zone of volcanic and earthquake activity that circles the Pacific Ocean, is home to most of Earth's active volcanoes. But even these volcanoes spend most of their time quiet. Years or decades can pass between eruptions, and when they do erupt, while it might be dramatic on the ground, from space, it's just a small plume of white or gray against the larger patterns of clouds and landscape, a brief moment of activity in the otherwise peaceful view. Ice sheets cover Greenland and Antarctica. These ice sheets are thousands of meters thick in places. They hold vast amounts of frozen water. If all the ice in Antarctica melted, sea levels around the world would rise by about 60 meters. But that's not going to happen anytime soon. The ice is stable. It's been there for millions of years, and it will be there for millions more, changing slowly, gradually, in response to long-term changes in climate. From space, these ice sheets look permanent, unchanging, like they've always been there and always will be, bright white against the blues and browns of the rest of the planet. Glaciers, smaller rivers of ice that flow down from mountains, are also visible from space in some places. They appear as white tongues extending down valleys. In polar regions, glaciers flow all the way to the ocean, where they break off into icebergs. From space, you can sometimes see these icebergs floating in the water near the coast. They're bright white against the dark blue of the ocean. Some are huge, kilometers across. Others are small, but they all drift slowly with ocean currents, gradually melting, eventually disappearing back into the sea. Lakes are scattered across Earth's continents. Some are huge. The Great Lakes of North America, for example, are so large that they're easily visible from space. They look like inland seas, bright blue patches surrounded by land. Other lakes are much smaller, just tiny dots of blue here and there. But each one is a reservoir of fresh water. Each one is important to the local ecosystem, and from space, they add variety to the landscape. They break up the monotony of land with touches of blue. They reflect the sky. They create their own small weather patterns. They're peaceful features, calm and still from orbit, even if there are waves on their surface. Deserts, as we mentioned, cover large parts of Earth's land surface. The Sahara in Africa, the Arabian Desert in the Middle East, the Gobi in Asia, the Atacama in Chile, the Australian outback. Each has its own character, its own color, its own patterns of dunes or rocks or dry lake beds. From space, deserts can be beautiful. The play of light and shadow across sand dunes create patterns that look almost artistic, almost intentional. But of course, they're just the result of wind and sand and time, natural processes creating natural beauty. Some deserts are sandy, others are rocky. The Atacama Desert in Chile is one of the driest places on Earth. In some parts of the Atacama, rain has never been recorded, not once, not ever. It's a landscape of rock and dust and nothing else. From space, it appears tan and brown and utterly barren. And yet, even this harsh place has a certain peace to it, a certain stillness. It's been there for millions of years. It will be there for millions more, unchanged, unchanging, patient. Rivers flow through deserts too, though they're rare. The Nile River flows through the Sahara Desert, creating a thin green ribbon of life in the middle of the sand. From space, the contrast is striking. Brown desert on both sides, a thin line of green down the middle where the river brings water from distant mountains, and then brown again beyond. For thousands of years, people have lived along the Nile, depending on its water for survival. And from space, you can see the results. Cities and farms clustered along the river, life concentrated in that one thin line, and vast emptiness everywhere else. The atmosphere of Earth is always in motion. Wind blows at all altitudes, driven by differences in temperature and pressure.
At the surface, these winds can be gentle breezes or powerful gales, but at high altitudes, the wind flows in great rivers of air called jet streams. These jet streams move from west to east, circling the planet at speeds of hundreds of kilometers per hour. From space, you can't see the wind directly, but you can see its effects. You can see how it shapes clouds, how it pushes them across the sky, how it creates patterns and swirls and lines. The jet streams affect weather on Earth. They guide storm systems. They influence where cold air goes and where warm air goes. In winter, the jet stream over North America often dips south, bringing cold air from Canada down into the United States. In summer, it retreats north, allowing warm air to dominate. These patterns are predictable to some extent. They repeat year after year, but they're never exactly the same. Each year is a little different. Each season brings its own variations, and that's part of what makes Earth so interesting, so endlessly varied, so impossible to get bored with. Auroras, which we mentioned earlier, are not visible from all parts of Earth. They occur mainly near the poles in a region called the auroral zone. If you live far from the poles, you might never see an aurora in your lifetime. But if you live in northern Canada, Alaska, Scandinavia, or Iceland, you might see them regularly. They're a gift of Earth's magnetic field, a visible reminder that our planet is protected, that we're safe here in our thin blanket of atmosphere, shielded from the harmful particles that stream constantly from the sun. From space, the aurora is a crown around each pole, a ring of light that glows softly in the darkness. Green is the most common color, but sometimes you see red or purple or blue. The colors depend on which gases in the atmosphere are being excited by the particles from the sun and at what altitude, but the details don't really matter. What matters is the beauty, the peace, the gentle glow in the darkness. Earth's magnetic field extends far out into space. It creates a bubble around the planet called the magnetosphere. This bubble protects us from solar wind, a stream of charged particles constantly flowing out from the sun. Without the magnetosphere, these particles would strip away our atmosphere over time. They would make the surface of Earth hostile to life. But the magnetosphere deflects them, sends them around the planet, keeps us safe. And it does this constantly, every second of every day, without any effort or attention from us. It's just there, working, protecting, an invisible shield that we rarely think about, but that's essential to our existence.
The moon, as we mentioned, orbits Earth. It takes about 27 days to complete one orbit, but because Earth is also orbiting the sun, it takes about 29.5 days for the moon to go through all its phases as seen from Earth. New moon, crescent, first quarter, gibbous, full moon, and then back again. This cycle has been observed by humans for as long as we've existed. We've used it to track time, to create calendars, to plan activities. The moon's phases are predictable, reliable, comforting in their regularity. From space, the moon is a constant companion. It's always there, somewhere in the vicinity of Earth. Sometimes it's visible, sometimes it's not, but it's always there. And for astronauts, seeing the moon can be a comfort, a familiar sight in the strangeness of space, a reminder that they're not infinitely far from home, that Earth is right there, just a few hundred kilometers below, and the moon is right there too, hanging in the blackness, reflecting sunlight, following its ancient path around our planet. The sun rises and sets on Earth about once every 24 hours, as we've discussed, but the exact length of a day varies slightly throughout the year. This is because Earth's orbit around the sun is not a perfect circle, it's an ellipse, and Earth's axis is tilted. These two factors combine to create small variations in the length of days. But these variations are tiny, a few minutes at most, not enough to notice in daily life, not enough to disrupt the gentle rhythm of day and night that governs our lives. At the equator,
day and night are almost always equal in length, about 12 hours of daylight, about 12 hours of darkness. This constancy creates its own rhythm, its own pace of life. But as you move toward the poles, the length of days and nights begins to vary more dramatically with the seasons. In summer, at high latitudes, the sun barely sets. In winter, it barely rises. And at the poles themselves, there are months of continuous daylight followed by months of continuous darkness. From space, you can see this. You can see the line between day and night moving across the planet, but moving differently at different latitudes, creating different experiences for people in different places. Earth's orbit around the sun takes 1 year, about 365 and a quarter days. That extra quarter day is why we have leap years. Every 4 years, we add an extra day to the calendar to keep our seasons aligned with the calendar dates. This orbit is nearly circular, but not quite. Earth is slightly closer to the sun in January than it is in July, but this difference doesn't cause the seasons. The seasons are caused by the tilt of Earth's axis, not by the distance from the sun. This is a common misconception, but it's not important to remember. What's important is just the feeling, the rhythm, the way Earth moves through space in predictable patterns, year after year, century after century, millennium after millennium. From space, you can't see Earth's motion through space. You can't see it orbiting the sun. Everything just looks still, peaceful, calm. And in a way, that's the truth. Even though Earth is moving at enormous speeds, spinning on its axis and orbiting the sun, and moving with the sun around the galaxy, from our perspective, from the perspective of someone on Earth or near Earth, everything feels still, because we're moving with it, because we're part of it, because this is our home. And home, by definition, is where we feel at rest. Satellites in geosynchronous orbit circle Earth at exactly the same rate that Earth rotates. This means they stay above the same point on the surface at all times. They appear to hang motionless in the sky. These satellites are used for communications and weather monitoring. From Earth, you can't see them with a telescope. They're too far away, about 36,000 kilometers up. But they're there, silent sentinels, watching, relaying signals, helping us communicate across vast distances. And from their vantage point, Earth appears much smaller than it does from low Earth orbit, but still recognizable, still clearly a planet, still home. The International Space Station, by contrast, is in low Earth orbit, only about 400 kilometers up. From this height, Earth fills most of the view. You can see individual countries, you can see weather systems, you can see cities at night. The detail is incredible, and the sense of connection is strong. Astronauts on the station often talk about feeling like they can almost reach out and touch Earth, like they're not really that far away. And in cosmic terms, they're not. 400 kilometers is nothing. It's less than the distance from one city to another in many countries. It's a short distance, close to home. When astronauts return to Earth after spending months in space, they often talk about appreciating simple things more. The feeling of rain on their skin, the smell of grass, the weight of their own body, the sound of wind in trees, the taste of fresh food. These are things we take for granted, things we don't think about. But after months in the artificial environment of a spacecraft, these simple, natural things become precious, become sources of joy. And that's a good reminder for all of us that the simple things matter, that Earth provides so much, that we're lucky to live here, in this place, with air to breathe and water to drink and food to eat and beauty all around us. But we don't need to have gone to space to appreciate these things. We can appreciate them right now, right here, as we lie in the darkness, breathing slowly, feeling peaceful and calm, we can be grateful for the simple fact of being alive, of being here, on this planet, at this moment in time. It's enough. It's more than enough. It's everything. Earth has been photographed countless times from space, by astronauts, by satellites, by robotic probes, and each photograph tells a story. Some show Earth in full, the entire planet visible in one image. Others show just a portion, a continent, an ocean, a storm system, but all of them share something in common. They all show Earth as beautiful, as peaceful, as special. No matter how many times you see it, the view never gets old, never becomes ordinary. It's always striking, always moving, always capable of making you feel something. There are photographs of Earth taken from the moon during the Apollo missions. In these images, Earth appears as a small blue and white sphere rising above the gray, barren lunar horizon. The contrast is stunning. The moon, gray and lifeless. Earth, blue and vibrant. These images are called Earthrise, and they're some of the most famous photographs ever taken, not because they're technically perfect, but because they show us our place in the universe. They show us that we live on a small, fragile oasis in the vast emptiness of space, and that realization is both humbling and comforting. Humbling because it reminds us how small we are, how insignificant in the grand scheme of the universe, but comforting because it reminds us that we have each other, that we share this small planet, that we're all in this together, and that should make us kinder to each other, more patient, more understanding, more willing to help, because we're all passengers on the same small ship sailing through the darkness, and we might as well make the journey as pleasant as we can for everyone on board. From space, you realize that Earth has no backup. There's nowhere else to go, no other planet we can easily reach, no other world that has everything we need to survive. Earth is it. This is our home, and we need to take care of it. Not in a frantic, urgent way, not in a way that creates stress or anxiety, but in a gentle, mindful way, making small choices, being conscious of our impact, appreciating what we have, and doing our part to preserve it for future generations. But again, these are just thoughts, just ideas floating by. You don't need to hold on to them. You don't need to do anything with them. You can just let them drift past, like clouds drifting across Earth's surface, like lights twinkling in the darkness, like the gentle rhythm of day and night, over and over, endlessly cycling. All you need to do right now is rest, breathe, feel peaceful, and let yourself drift toward sleep. The solar system, of which Earth is a part, contains 8 planets. Earth is the 3rd planet from the Sun. Closer to the Sun are Mercury and Venus. Farther away are Mars, Jupiter, Saturn, Uranus, and Neptune. Each planet is different. Each has its own character. But none of them are like Earth. None have liquid water on their surface. None have an atmosphere like ours. None have life, as we know. Earth is unique, special, and when you look at images of other planets, barren and lifeless, it makes you appreciate Earth even more. Mars, our nearest planetary neighbor, has been photographed extensively. It's a cold, dry world, covered in red dust, with a thin atmosphere that's mostly carbon dioxide. There's ice at the poles and possibly underground, and there's evidence that liquid water once flowed on the surface billions of years ago. But today, Mars is a desert,
A beautiful desert with canyons and mountains and dust storms, but still a desert, lifeless, silent. And when you compare images of Mars to images of Earth, the difference is striking. Earth is alive. Earth is vibrant. Earth is home. Venus, on the other hand, is a hellish world, covered in thick clouds of sulfuric acid, with a surface temperature hot enough to melt lead, and an atmospheric pressure 90 times greater than Earth's. No human could survive there. No spacecraft has lasted more than a few hours on the surface before being crushed and melted. Venus is beautiful from a distance, shining brightly in our sky, but up close it's a nightmare. And again, this makes us appreciate Earth, our gentle, hospitable, comfortable home. The gas giants, Jupiter and Saturn and the others, are completely different from Earth. They have no solid surface. They're just enormous balls of gas and liquid with small rocky cores deep inside. You couldn't land on them, you couldn't stand on them, you could only fall through their atmospheres until the pressure crushed you. These planets are magnificent. Jupiter's great red spot, a storm larger than Earth that's been raging for centuries. Saturn's rings, made of countless particles of ice and rock. But they're not places we could ever call home. They're just neighbors, distant, beautiful, fascinating neighbors in our solar system. Earth is the only planet we know of that has life, the only one with forests and oceans and animals and people, and that makes it precious beyond measure. Scientists have discovered thousands of planets orbiting other stars. These exoplanets come in all sizes and types. Some are rocky like Earth, others are gas giants like Jupiter. Some orbit very close to their stars, others orbit very far away, and a very few, are in what's called the habitable zone, the region around a star where temperatures are just right for liquid water to exist. These planets might be like Earth. They might have atmospheres and oceans and maybe even life, but we don't know. They're too far away to study in detail. We can only observe them from a distance and wonder. The nearest star to our Sun is about 4 light years away. That means light, traveling at 300,000 kilometers per second, takes 4 years to reach us from that star. And light is the fastest thing in the universe. Nothing can go faster. So even if we could build a spacecraft that traveled at the speed of light, which we can't, it would take 4 years to reach the nearest star. And most stars are much farther away than that. The stars you see in the night sky are dozens or hundreds or even thousands of light years away. The universe is vast, almost incomprehensibly vast, and Earth is just one tiny speck in that vastness. But that tiny speck is our home, and from space it's the most beautiful thing you can see, more beautiful than any star, more beautiful than any galaxy, because it's ours, because it's where we belong, because when you look at Earth from space, you're looking at home, and there's no sight more comforting than that. As you lie here tonight, feeling peaceful and relaxed, you can think about all of this, or you can think about nothing at all. You can just breathe, just rest, just let your mind wander where it wants to go. There's no pressure, no expectations, no right or wrong way to do this. You're just here, in the darkness, safe and comfortable, and that's enough. Earth will keep spinning, the sun will keep shining, the moon will keep orbiting, the seasons will keep changing, life will keep going, and you'll be part of it all. Tomorrow, you'll wake up, you'll go about your day, you'll do whatever you need to do. But right now, none of that matters. Right now, you're just resting, just being, just existing peacefully in this moment. The view of Earth from space is a gift, a perspective that helps us see things differently, that helps us appreciate what we have, that helps us feel connected to something larger than ourselves. And even if we never go to space ourselves, even if we only see this view in photographs and videos, we can still benefit from it. We can still let it calm us, still let it put our worries into perspective, still let it remind us that we're part of something beautiful, something vast, something that's been here long before us and will be here long after us. Cities on Earth are centers of human activity. They're where people gather to work and live and create. From space, during the day, cities blend into the surrounding landscape. You can't really pick them out unless you know where to look. But at night, they glow. They announce themselves. They say, "Here we are. Here's where people live." And there's something comforting about that, knowing that even in the darkness, even in the vast emptiness of space, there are lights, there are people, there's life.
The largest cities create the brightest glows: Tokyo, New York, London, Shanghai, Cairo, Mumbai, Sao Paulo. These megacities spread for dozens of kilometers in every direction, and from space, they're clearly visible, bright patches of light against the darkness. But even small towns contribute to the glow. Even individual homes far from any city add their tiny bit of light to the picture. And together, all of these lights create a map of human civilization. A map that's constantly growing and changing as populations shift and new cities emerge and old ones expand. But between the lights, there's darkness, vast areas of darkness, oceans, deserts, forests, mountains, places where humans don't live or live only sparsely. And this darkness is important too. It's a reminder that we don't dominate the planet, that there are still wild places, still quiet places, still places where nature exists on its own terms without our interference. And from space, this balance between light and dark, between civilization and wilderness, creates a peaceful pattern, neither overwhelming the other, both coexisting, both part of what makes Earth home. Weather patterns on Earth are driven by the sun's energy. The sun heats the surface unevenly. The equator receives more direct sunlight than the poles. Warm air rises at the equator and flows toward the poles. Cold air sinks at the poles and flows back toward the equator. This creates circulation patterns in the atmosphere, and these circulation patterns, combined with Earth's rotation and the distribution of land and sea, create the weather we experience: wind, rain, snow, clouds, sun. All of it driven by the simple fact that the sun shines on Earth, that energy flows from the sun to our planet, and that this energy creates movement, creates change, creates the dynamic, ever-shifting patterns we see from space. But even though weather is constantly changing, there's a predictability to it. Storms form in certain regions, trade winds blow in certain directions. The monsoon comes at certain times of year. These patterns have been observed for centuries, for millennia, and they continue today. From space, you can see these patterns. You can see how weather moves, how it flows from one place to another, how it's all connected, one great global system, one atmosphere shared by everyone on the planet. The tropics are the wettest part of Earth. This is where most of the rain falls, where most of the thunderstorms occur. The air here is warm and humid. It rises easily. And as it rises, it cools and its moisture condenses into clouds and rain. From space, the tropics are almost always covered in clouds, thick, white, towering clouds that produce torrential rain. But this rain is life-giving. It feeds the rainforests, it fills the rivers, it sustains the incredible diversity of life that exists in tropical regions. The polar regions, by contrast, are the driest part of Earth. The air here is cold. Cold air can't hold much moisture, so even though the poles are covered in ice, the actual amount of precipitation is very low. Antarctica is technically a desert. It receives less precipitation than the Sahara, but because it's so cold, the little snow that does fall never melts. It accumulates over thousands of years, building up into the ice sheets we see today. From space, the contrast between the wet tropics and the dry poles is clear. It's all part of Earth's diversity, all part of what makes our planet so interesting, so varied, so endlessly fascinating. But you don't need to be fascinated. You don't need to be interested. You can just let all of this information wash over you. Let it be background noise. Let it fade into the quiet of the night. What matters is that you're relaxed, that you're comfortable, that you're drifting closer to sleep with each passing moment. The Indian Ocean, the Atlantic Ocean, and the Pacific Ocean, these great bodies of water cover most of Earth's surface. The Pacific alone covers nearly a third of the planet. It's vast, so vast that you could fit all of Earth's land masses into it with room to spare. From space, when you're looking at the Pacific side of Earth, almost all you see is blue, just water, scattered with a few small islands, but mostly just water. Deep, dark blue water stretching in every direction. And there's a peace to that, a simplicity, a reminder that Earth is first and foremost a water planet, a blue marble, a precious sphere of liquid and life floating in the darkness. Coral reefs are visible from space in shallow, clear waters. They appear as lighter patches of blue or turquoise near coastlines and around islands. These reefs are some of the most diverse ecosystems on Earth, home to thousands of species of fish and coral and other marine life. But from space, they're just pretty patterns, just variations in color, just another beautiful detail in the overall view of Earth. You don't need to understand them, don't need to know about them. They're just there, part of the picture, part of the piece. The Antarctic ice sheet is so large that it affects Earth's climate. It reflects a huge amount of sunlight back into space. This helps keep the planet cool. Without Antarctica's ice, Earth would be warmer, sea levels would be higher, weather patterns would be different. But Antarctica is stable. Its ice has been there for millions of years. And while there are concerns about climate change affecting the ice, these changes happen slowly, gradually, over decades and centuries, not overnight, not in ways that should cause immediate worry. From space, Antarctica looks eternal, unchanging, a bright white continent at the bottom of the world, a quiet, peaceful presence. Ocean currents circulate heat around the planet, as we mentioned. They also circulate nutrients, and they affect where marine life is abundant. Areas where cold, nutrient-rich water rises from the deep are particularly productive. These upwelling zones support huge populations of fish and other sea life. From space, you can sometimes see hints of these areas, places where the water is slightly different in color, places where there might be more plankton, turning the water a slightly greener or milkier shade. But mostly, the ocean just looks blue, dark, deep, peaceful blue. Sunlight penetrates only the upper layers of the ocean. Below about 200 meters, it's dark, completely dark. The deep ocean is a realm of eternal night, and yet,
life exists even there. Strange creatures adapted to the darkness, to the cold, to the pressure. But from space, we can't see any of this. We can only see the surface, the thin skin of water that separates the ocean from the air. And that surface is calm, peaceful, reflecting the sky, hiding the depths below. Earth's atmosphere is made mostly of nitrogen and oxygen. These two gases make up about 99% of the air. The remaining 1% includes argon, carbon dioxide, water vapor, and trace amounts of other gases. This mixture is what we breathe, what keeps us alive, and it's been remarkably stable for millions of years. The oxygen in our atmosphere comes mostly from plants, from photosynthesis. Plants take in carbon dioxide and release oxygen, and we breathe in oxygen and release carbon dioxide. It's a cycle, a balance, one of many cycles that keep Earth habitable. Carbon dioxide, though it makes up only a small fraction of the atmosphere, plays an important role. It helps trap heat. Without any carbon dioxide, Earth would be much colder. But too much carbon dioxide, and Earth becomes too warm. Right now, the amount of carbon dioxide in the atmosphere is increasing. This is causing Earth's average temperature to rise, and that's a concern for the future. But from space, right now, Earth looks peaceful, beautiful, the same as it always has. The changes are too gradual to see from day to day, or even year to year. They happen slowly, over decades, over a human lifetime. But in this moment, in this peaceful nighttime view, Earth is simply beautiful, simply home. You don't need to worry about the future right now. You don't need to solve problems or think about complex issues. Right now, you just need to rest, to breathe, to let yourself relax completely, to let go of the day and to prepare for sleep. And thinking about Earth from space can help with that. It can provide perspective. It can remind you that some things are larger than your individual worries, that the planet keeps turning, that life keeps going, and that you're part of it all. A small part, perhaps, but an important part, because every person matters. Every life has value, and you deserve rest. You deserve peace. You deserve this quiet moment in the darkness. When the sun rises tomorrow, Earth will look different from space. The night side will become the day side. The lights of cities will fade away, replaced by the bright colors of continents and oceans and clouds. And the cycle will continue, day and night, over and over. A rhythm that's been repeating for billions of years and will continue for billions more. There's comfort in that, in the predictability, in the certainty, in knowing that no matter what happens in our individual lives, Earth will keep spinning, the sun will keep shining, and life will keep going. Thank you for spending this time together, for allowing yourself to relax, for imagining Earth from space with me. If this has helped you feel more peaceful, more calm, more ready for sleep, then that's wonderful. And if you'd like more videos like this, you're welcome to explore the Late Night Science channel. But there's no pressure, no urgency, just an invitation, just a quiet suggestion. You can come back whenever you need to, whenever the world feels too loud, whenever you need a reminder of the bigger picture, whenever you need to rest. For now, just let yourself drift. Let your breathing slow. Let your body sink into the bed. Let your mind go quiet. Earth is out there, spinning in the darkness. The moon is orbiting. The stars are shining. And you're here, safe, comfortable, at peace. Everything is okay. Everything will be okay. You can let go now. You can sleep. Good night.